Hello, this is Math 2231 coming to you from the College of DuPage during the summer 2020, and this is the conclusion of the lecture entitled The Chain Rule, Derivatives of Composite Functions. Here's an example. Cosine to the fourth t plus cosine of t to the fourth. Now that first function means that is cosine of t whole to the fourth. So when we take the derivative of that, we're going to do 4 times cosine of t whole to the cubed times the derivative of what's inside, which is cosine of t, and the derivative of that is negative sine of t. Then we go to the next one. On the outside is the cosine. The derivative of the cosine is the minus sine of that business times the derivative of that business, which is 4t cubed. So this is another way to write that answer. Again, I'm probably going to have you plug in the numbers. Here we have f of z is equal to the sine of z times e of z. Notice that we have a product inside. So we start on the outside, so the derivative is going to be the cosine of z e to the z, but now I have to take the derivative of this. That's a product. So it's going to be the derivative of the first times the second plus the first times the derivative of the second. So this is the answer to that problem. Here I have a quotient, but look, I have the chain rule in the numerator and the chain rule in the denominator. Wow. Okay. So we start on the outside. It's the quotient. So it's going to be denominator times the derivative of the numerator. Now the derivative of the numerator is going to be 5 this business to the fourth times 3x squared. So that concludes the denominator times the derivative of the numerator. Minus, this is going to be the numerator, and now we're taking the derivative of the denominator. Now this is going to be 1 minus 2x squared whole squared times the derivative of what's inside, which is minus 4x. And this is all over the denominator whole squared. Now when you do all of this, you're going to get you're going to get this to the 6th power, and that looks pretty messy to substitute numbers in, but look what you can do. You can factor out 1 minus 2t squared, like I did here, and I'm left with this, and then this will cancel with that, and that will make it a little bit cleaner once I do that, because I'll have this to the 4th power, and I multiply all this stuff out and simplify it. Again, we're doing the quotient on the outside and then the chain rules on the inside. Here, the function on the outside is this cubed, but inside is a quotient. So the derivative of this is going to be 3 times this business squared. And then I have to take the derivative of the quotient. So it's going to be the denominator times derivative of the numerator minus the numerator times derivative of the denominator, all divided by the denominator whole squared. And again, there's some simplification that can happen like this, but that is how you take the derivative. The rest is algebra. Let's look at this one. The best way to look at this is as this h of z is 2, 4z plus e to the minus 9z whole to the minus 10. You could use the quotient rule, but this is simpler. So what we're going to do is the 2 just sits there, so this is going to be minus 10 times 2 is minus 20. This business, I subtract 1 to the minus 11, and then I take the derivative of what is inside. So that is going to be 4, and then this is going to be e to the minus 9z times the negative 9, because that is the chain rule. And so this is our final answer. Here on the outside you have the square root, on the inside you have a bunch of things and a lot of chain rule going on here. But let's just start with the outside and go there. So this is going to be 1/2 this business to the minus 1/2. Then I'm going to take the derivative of what's inside with respect to y. So that is going to be 2. And then here it's going to be 3 that business squared times the derivative of what's inside, which is 3 plus 8y. And if you simplify it using some algebra, you get this. Here on the outside we have a function cubed, and it's cubing the sine, and then it's the sine of this, and there's quite a bit of chain rule going on with this. So it's going to be 3 times the sine squared of this business times the derivative of the sine of this. Now the derivative of the sine of this is going to be the cosine of this times the derivative of what's inside. So it's the cosine of this, and the derivative of e to the 1 minus t is e to the 1 minus t times minus 1, plus the derivative of this is going to be the 3 just sits there. The derivative of the sine is the cosine of 6t times 6. And then you can simplify this. There were, I think, 4 chain rules here in this problem. Finally, closing comment. Remember that I told you if f of x was equal to e to the x, the derivative was just e to the x. But now what we see is, and I told you that if it was a, not e, if it was a to the x, it was f prime of x is equal to a to the x, but then this constant was the logarithm. Now I can actually show you that, because you see the exponential and the logarithm are inverse functions one with another. So when a is the same thing as e to the ln of a, and that will be then e to the ln of a times x. So that means that that is x times ln of a. Ln of a is a number. So if I take the derivative of this, it's going to be e to the u, or e to x ln a, times the derivative of this with respect to x, and that's going to be ln a. So you see, this is a way to justify this, but we needed the chain rule to provide that justification. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. Take care of yourself and of each other.